I'm gonna give it another minute. It seems like we've Jesse, we've got 200 people. That correct?
Yeah, we can give it one more minute.
Yeah, I think that's a good idea. Well, it appears that our participant entrance people has slowed down. So I want to welcome again fellow air quality stewards to the second session of Data Centers and Air Quality Permitting Challenges and Pathways today. My name is Mark Cohn, the Executive Director of the Mid-Atlantic Regional Air Management Association, and I want to start by thanking Sana and Tamara for providing us an outstanding introduction to data centers and air quality. Today we have Justin Wilkinson and Stan Faggart from Virginia DEQ and Sana from MDE again to talk about permitting challenges these operations create. I also want to say thanks for Jessie Carpentier of my staff for doing an awesome job in managing this project and her handling of the questions. We will have the chat feature turned off until the end of the presentation and then open it for questions. Thank you. And with no further ado, Justin, take us away.
Stan, that'll be you.
Yeah, Mark, I think I'm actually going to start off for Virginia anyway.
Okay.
Yep, no problem. I am Stan Faggart. I am DEQ's Minor New Source Review Coordinator. I'll be joined, or kind of Justin Wilkinson, who is our Northern Virginia Air Permit Manager, will kind of take over partway through our presentation here and close things out for us. Just generally, I'm going to try to kind of just broadly describe Virginia's permitting program that we've been using mostly for data center permits, and then Justin will get in a little bit into the nitty-gritty details of what some of those actual permit activities look like or have entailed. So I guess next slide. Thank you. So again, very briefly, in Virginia, we have, of course, like most states, a federal operating permit program for Title IV and V. We have a Virginia state operating permit program, which is primarily a Title V avoidance tool for existing sources. And again, like many states, we have, and I guess also some local agencies, we have our new source review program, which includes, of course, the major NSR element for PSD sources and non-attainment. And then we also have our state minor new source review permit program, which is primarily a major NSR avoidance tool. Then kind of circling back to the non-attainment aspect, and I think Tamara talked about this a little bit last week, most of the data centers in Virginia to date have gone into our the Northern Virginia part of the state. And that is primarily designated currently as a moderate ozone non-attainment area under the 2015 standard. We're hoping to have that.
It'll stay moderate because it's in the OTR.
Well, just from the actual air quality standpoint,
right,
we're going to have it redesignated as attainment. Okay. However, we will remain, right, based upon clean data, but we will remain, or that area of the state will remain or can still be considered a non-attainment area because of its inclusion in the ozone transport region. But just from a clean data standpoint, we're hoping to get back to attainment for that standard. And that will be some importance or relevance to some later slides. All right, so next slide. So this is, of course, a map with some of the data centers known and then proposed data centers we have in the Northern Virginia area. And again, I think Tamara may have touched upon this a little bit last week. Currently, the number is 172 data centers. And I'm going to stop right here just because sometimes we've struggled, at least I have, with kind of a nomenclature issue about what some people consider a data center versus what other people might consider a data center to mean. Of course, we mean data center stationary sources, right? So that's 172 separate stationary sources that, the primary activity is a data center. A few years back, I guess, we ran into some issue where a lot of press were reporting that number is 300. They were describing Virginia being the home of 300 data centers. And we had people come into us and say, well, why are you only saying you have 100? Because that's, at that time, we only had about 100 stationary sources that were data centers. And we're like, and there's just that disconnect, right? A data center for us might have multiple buildings that, some people would count as separate data centers. Whereas for us, if they're all part of the same stationary source, in the permitting world, that's just one data center. Again, they all have minor new source review permits in Northern Virginia, and I think pretty much the rest of the state as well. And so far, we've only had 2 that have triggered Title V requirements. Next slide. So a little more detail about our minor new source review permitting program. I think, again, some of the state folks on may have participated in the recent EPA exercise or discussion group about trying to maybe harmonize some of the public participation requirements for minor new source review across the country. Right now in Virginia, that is not required automatically for our minor new source review permits, except for certain large increases in PTE that don't trigger major NSR, and that threshold is 100 tons for projects of new stationary sources, or for certain applications that have the potential for public interest concerning air quality issues. And that air quality issues part is important because a lot of the, I'll say much of the public opposition to data centers has really been more about local issues, zoning and noise issues, and maybe local land use issues. And so far, we have not had a lot of pushback on actual air quality issues. Then again, broadly for all of our minor new source review permits, permit limitations must be enforceable as a practical matter. And we do have a minor source BACT, or best available control technology, component with our regulation. Next slide. Actually, Jesse, can you go back one? I realized I left something off there. So one thing I forgot to put on the slide, but I didn't make note of, and it kind of goes in with the local air quality issues I was talking about, or the local issues that were not air quality, excuse me. We do also have, for new stationary sources, a requirement that applicants get what we call a local governor body certification form, where that more or less gets the locality where they're locating to certify that that facility will be in compliance with any of that locality's zoning or other requirements. And that's a prerequisite to us issuing the permit. So that's really what we've relied on to date anyway, as a tool to address any noise issues or siting issues. And while we have not had to deal with that in a public participation setting. All right, now next slide. Thank you. So again, just briefly touching on BACT, we don't normally require the full top-down process that's used for PSD permits. We sometimes do that if we have it. We would find ourselves in, I guess, substantial disagreement with an applicant. We'll fall back to that process. But for many source categories, we have what we call presumptive BACT that have been established in formal guidance documents, and we do have one of those for diesel engines. However, as per the general theory and legal concept of BACT, the regulation does still allow for case-by-case determinations. Next slide, please. So specifically looking at engines, the presumptive back guideline we have basically distinguishes between emergency and non-emergency engines. And the critical pollutant here is NOx. For emergency engines, we have a standard of 6.0 grams per horsepower hour, whereas for non-emergency, that goes down to 6.0 for emergency, whereas for non-emergency, that goes down to 0.6. And of course, SCR is the most common way of achieving that 0.6 standard. I will say, excuse me, that the 6.0 for emergency engines is applied at max capacity as opposed to over the full load range of an engine. So we normally implement that in a permit through an hourly emission limit that's based upon the maximum capacity of the particular engine and horsepower. And I will also say that I mentioned that we sometimes deviate, that we really have stuck with that 6.0 number for emergency units at data centers, particularly in the Northern Virginia non-attainment area. There have been some engine manufacturers that have basically, and some applicants for that matter, that have basically made arguments trying to get us to raise that number based upon vendor data. But we have found through, at this point, a great deal of source testing that folks can meet this standard if they've set their units and their engines up correctly. And so we do not deviate from that 6.0 very often, or really at all, as far as I know. Next slide. And I guess this is just a quick note about the definition of emergency versus non-emergency units. And I'm not going to get into this in great detail because this is kind of an issue that has a long history here in Virginia, and one that we're still, to some degree, still struggling with at both the state legislature level as well as a DEQ regulatory level. But our definition of emergency does not provide the 50-hour non-emergency allowance that EPA's engine rules provides. And so that creates a kind of an additional restriction on the operation of the units that we permit as emergency here in Virginia. And we don't really have any real data, I guess, to the engine level, but this is one of the things that we think has helped us minimize emissions from data centers, despite the large number of data centers we now have, and of course the large number of engines those data centers have. For example, you'd have some sources that would turn their emergency engines on as a storm avoidance measure that is not allowed under our definition of emergency. So those are emissions that we are able to avoid so far for the emergency engines here in Virginia. Next slide. And then this is one more consideration for our minor new source review permitting program. And we did get some questions on this last week, so this is why I included this slide today. So modeling or air quality analysis, again, is not required by our minor new source regulation for any particular application. What we do instead is kind of more of a case-by-case analysis, where if we have emission increase that's above a certain threshold, we'll contact our modeling group and get some feedback from them whether they think modeling should be required for a particular situation. Generally, they're looking at, are there other nearby sources that are large emitters? What is the topography for that area? What do the background ambient monitors show? Those are the kind of things that they consider when we're looking at whether to require modeling for a particular application. For data centers as a source category, because of the intermittent operation of those engines and just the overall relatively low utilization of them, so far our modeling group has not determined that any modeling was required for a particular data center. Now, that said, we are starting to get some applications outside of the non-attainment area for some new stationary sources or new data centers that will have more than 100 tons per year of allowable emissions. And so for those sources, we're definitely looking at requiring modeling. And those sources, as I mentioned earlier, would also trigger the requirement for public participation and just kind of in general enhanced review. And then the last point I would make here is just for the minor new source remodeling we have done, not for data centers, but for other source categories in the past, typically we have found that the impacts are very small relative to the NACs and usually very close to the facility boundary. So that, again, just that historical context is part of, again, what informs our decision not to require modeling for every minor new source review source. And next slide. And again, this is one based upon some of the questions we included from last week, we included today. And this is a graph of kind of the megawatts of permitted data centers in the Northern Virginia area that you can see has increased over time versus the design value of our background ozone monitors, also in Northern Virginia, which in general has declined. And it's not that we're suggesting that you should get 150 or 200 data centers as an answer to your ozone problems. But I think what this does illustrate is that we've done a fairly good job of managing the emissions from the data centers that we permitted to date, and still maintained or continued to improve air quality in Northern Virginia as well as the state as a whole. And some of the slides that Justin's going to go through, I think, will kind of illustrate some of the emissions impact that have led to this, the data that we're seeing in this graph. But next slide. And I think at this point, I will turn it over to Justin.
All right, Stan, I appreciate everything. If you wouldn't mind, Jesse, could you back up just one slide? I just want to hammer some points home here. And this is just a huge success story for us as regulators. Permitting 172 data centers with over 7,000 engine gensets, able to produce over 17,000 megawatts. Now that chart's a little bit old, but 17,000 megawatts of power, which can power up to 3.4 million homes, and still see some monitored, improvements in air quality. It's just pounding home what a success it has been. It's very rewarding to see as a regulator. I know sometimes I'll opine for a minute. Sometimes it's very hard for us as regulators to really see the big picture, see that we're having impacts. But just want to point out that, what we do is important. And on the big picture, the big level, we are making a difference. So I just want to encourage everyone to keep up the good work and continue down the path you're going on. So anyway, next slide. So I'm Justin Wilkinson. I'm the Regional Air Permit Manager for DEQ's Northern Regional Office. We have, we're the region of the home of the data centers, or the data center capital of the world. It starts not but 10 miles west of our office in Woodbridge. And it's just been a very rewarding thing for me to be a part of for the last 20 years of my career in both compliance and permitting. But I will say that I don't do it alone. We have a great team at DEQ, starting with my staff, who are consummate professionals, and really the expertise and customer service that they provide, not only to the regulated community, but to the citizens in the Commonwealth, is just impressive. We have a great management structure who's very supportive. And our technical staff like Stan and Tamara down in central office we're all a big team, and I'm very proud to be part of that team. Next slide, please. So, how on earth have we had such growth in emissions units in our region, and we're still, seeing some some improvements in air quality. Like Stan said, the engines are not scrubbing the air clean, right? So, how are we going about doing it? Now, the one way I like to think about data centers is that there's lots of bottled up potential to emit, but it's not necessarily being fully exercised. So here on the graph, we just pulled an example from five data centers that we have. The green, the highest bar on the left of each one of those data centers is what we refer to as the uncontrolled emission rate. So that's a calculation, and this is in NOx. So that's our NOx emissions from these units, from these facilities, without any federally enforceable limitations, without controls. And since these were all emergency units, we calculate those on 500 hours of operation for each one of those units. So if we were calculating it on, 8760 operation, you would see that green chart, green bar go way higher. But this is what this is the doom and gloom bar number. So if you're an opponent to data centers, then this is the emissions that you're saying is coming from all the emission units, the diesel engine generator sets. And if they were to all run at one time and at maximum capacity, there could be some disastrous impacts. But now the green bar in the middle, the lighter green shade of green, is after we have looked at them through the permitting process. So when we have put operational controls on the facility, emission limits, taking into account pollution control devices. These are the limits that the facility is taking to stay at a major source threshold, to not trigger non-attainment new source review. So this is what we refer to as their potential to emit. So facilities can, if they had emergency events, run up to the numbers there. And just to be clear for Virginia, because I know how other states might do it a little bit differently. Our emissions accounting from operations of the units include everything from initial commissioning, scheduled maintenance checks, readiness testing, stack testing, operator training, and the actual emergencies that facilities are going to be operating for. So when they come to us and they're taking a limitation, it is for all operations at the facility, including emergency. And then the bar all the way to the right of each one of those data centers is their actual emissions. This is what we actually see coming out of the data centers. So as Stan referred to our definition of emergency, it's very strict. It's more strict than NSPS Quad I for some of the reasons that Tamara mentioned in the first webinar concerning our grid reliability, that data centers are typically only operating for their maintenance checks and readiness testing at low or no loads. These are some of the reasons why we don't see actual emissions from the facility that are very large. I think these numbers are a little bit low. I would probably put about a third of the permit limit is what we would usually see as PTEs or what we would see every year. But that side of the bar is for the proponents of the data center community going, okay, we're putting in all these emission units, but our actual emissions are not that impactful. All right, next slide, please. So getting into to the permitting aspects, and one of the first steps of our process is making a single stationary source determination. As Stan mentioned, there are 172 where the papers have noted, media has noted that there are many other data centers in our region than what we have permitted. That's largely, if you look at the graphic here, it's largely because some count each building as a separate data center, where what we are trying to do is make a single stationary source determination and kind of put a box around that entire facility. So we make single stationary source determinations with the three-prong test. First we're asking ourselves is, does that facility and surrounding facilities belong to the same industrial grouping, SIC codes? Number two, are they located on one or more contiguous and adjacent properties? And three, are they under the control of the same person or persons with common control? So because the data center proliferation in our region, it's become more and more difficult for parts 2 and 3 of that three-prong test. As you can see in the graphic, we have clusters of data centers that in this situation, we have determined that there are 13 separate single stationary sources. Whether it's the reason because they're not contiguous and adjacent or they're not under common ownership. But there are reasons why we have made determinations or at least agreed with their analysis that they are separate stationary sources. So this, in our region, as they have continued to grow, this has become more and more difficult to make determinations of. And the third prong, the common ownership, it's not too big of a hurdle, but data centers also like to assume names under LLCs or things that you wouldn't even anticipate being a data center, like Northern Virginia Pineapple Farms LLC. I'm not sure if anyone's aware, but we are not a large exporter of pineapples. So when we get situations like that, and we can't identify that owner, then we're having to use methods to try to figure that out, whether it be going to county records or just searching our state corporation commission or just dealing with the source or the applicant in a manner that we can get to some of those answers. All right, next slide, please. So even after we have made a single stationary source determination, because of the growth, those can change. We've had instances where we have determined that two sources, in this case, the purple and the blue, were single stationary sources on their own merit because they were separated by a parcel of land that was owned and operated by a different ownership. So we didn't have common ownership and we didn't have contiguousness or adjacency. So data centers are funny in that they have land acquisition teams and design teams, and usually doesn't go down to the environmental until some of the last steps. So in this case, a facility had purchased the blue and the purple, who were same owners, purchased the land in between, then causing what we did have two separate stationary sources as one single stationary source. So just add that could be changing, and each time you get into those situations, you really have to dig in and define that source. All right, next slide, please. All right, so once we've kind of put a box around what the facility is that we are going to be evaluating the units, the emission units for both permit and backed applicability, we're then looking to define the new source of the project. So in Virginia, if you are dealing with a new stationary source, that's a source at a greenfield, so nothing was there before. Once we have an existing source, then everything that might come in after that, we then look at as a project. So for my Virginia folks, I'll apologize because I'm going to constantly interject new source and project, but I know you guys know what I mean. So, so one thing to also think about data centers, it's not just the emergency generators. We have other things, other emission units that go in at data centers that we need to be evaluating during the permitting and the backed applicability process. So other emissions that you might see are emission units like fuel storage, boilers, engine-driven fire water pumps and cooling towers. Now in Virginia, the fuel storage and the boilers will usually fall into what I call a categorical exemption, permit exemption. And we don't include those in the uncontrolled emission rate calculations or the permits. But fire water pumps and cooling towers, even though on their own merit might have a low UER, when they're usually aggregated or added in with the emergency generators, the generator sets that we see, they then become part of the permitting project and may be incorporated in the permit. So just be aware that, that data centers have other emission units besides the generator sets out there. So, all right, next slide, please. So one thing that makes the data center industry so interesting for us is how rapidly things might change. For us, when we issue a permit to a data center, we can usually expect that they are looking to expand that data center after they've received their initial permit. And I will say that every permit you get, you're usually writing the permit 2 or 3 times, because several times throughout that process, they're coming back to us with requested changes to the application, because they're changing the number of units or the type of units or models of units. So it is a long process from the start of the application to actual issuance. And then I'd be willing to bet that that's not the last time you're going to hear from that source. So this is an actual example that we have, and I will say that this is typical for us. Where in 2020 we issued a permit to a data center for 21 emergency engine generator sets. And in 21, 23, 24, and 25, they have come back for an expansion or changes to those units that they originally had permitted for. All right, next slide, please. So as we're trying to put that box around what the facility is asking for, defining that project, it's very important that we're also looking at what's occurred in the past. In Virginia, we basically have a 5-year look back period where we look at the new stationary source or projects that have occurred along the way, and determine if the changes that they're making are done in an incremental manner to avoid either permitting or back applicability. So if we start to not be able to separate those projects out, then we have to look at them together, and we refer to that and call that project aggregation. So here you can see that this is from the last example, that if we were to treat each one of those actions on their own, our BACT, the initial one, we would have only triggered NOx for BACT. But as they have gone along, and if we aggregate them all together in the end, then you're seeing that we're triggering way more pollutants for BACT. Now, I will say that we don't wait until action 5, then to aggregate. We're usually aggregating along the way. So as we were, to receive action 2, then we're combining that or aggregating that with action 1, and we're looking to see what BACTs were applied. So even though we might be working on that second action for units that they're going to be installing, they may have triggered BACT for other pollutants that we didn't, initially evaluate for or go through that process for. So we're having to go back and do either BACT validations or revalidations, or determining a new BACT for other pollutants in the first action as well. So I always like to say that a greenfield source, a new stationary source for us is typically one of the easiest permits we're going to work on for a data center. Everything thereafter definitely becomes more and more difficult to go on, and project aggregation is just one of those reasons. All right, next slide, please. So in determining BACT, we run a calculation called the uncontrolled emission rate, and that's going to tell us our permit applicability and also our backed applicability. So emergency engine gensets, we take the emission factor and multiply that by 500 hours, and that becomes our UER for that unit, but we're looking at it as a new stationary source or a project, and then compare that with our permitting thresholds in our minor new source review permit program. For all other units, but especially the non-emergency engines, because that's what we're concentrating on, we're using 8,760 hours. So assuming 365 days a year, 24 hours a day operation. Next slide, please. So how do we come up with the emission factor? I've been around for 20 years, so I'm able to say back in my day, or the good old days, we didn't always have manufacturer's information, which gave us emission factors or the emission profiles of the units. We were typically going to AP42 or to FIRE to get our pound per hour emissions and rolling through the calculations from there. But nowadays, we can get supplied manufacturers information or guarantees. And this is what we use to determine the emission factors from the engine generator sets itself. So, one thing I want to note is that, facilities will come to us and want to use the tier values for the EPA certifications, but that's just not appropriate. Tier certifications, tier values are weighted average values. If you're in a real pinch or pickle, you can use those. The NSPS Quad I allows for you to apply a 25% factor onto it, and you can use those for case-by-case emissions limits determinations. But for us, we have not really struggled with being able to get the manufacturer certifications. I'll also make a note here that not every manufacturer to manufacturer is the same. So not all Caterpillars are identical. Not all 3516C HDs are identical. Each one of those is going to have its own unique performance package. So you really want to identify what units the facility is wanting to put in and getting the appropriate and associated specification sheets that go along with those units. It's very important. And also, even the performance packages from year to year might change in their emissions guarantees. So it's just very important that you go to the facility and you're getting the spec sheets that you're, actually applying to your determinations that you're making. All right, and here, I want to know when you do get your specifications, we're looking at the emissions from all load levels, within the unit. So we're trying to identify the most conservative values or the worst case values through them. So we're using the not to exceed values provided by the manufacturer, or what some refer to as the rated speed potential site variation. And we're looking across all load levels to identify, worst case emissions, worst case scenarios. Some manufacturers will provide the 10% guaranteed numbers, but won't necessarily guarantee it. They will make arguments as to why we should not include those in our emissions evaluations. So we will evaluate those arguments on a case-by-case basis to determine what emission factors supplied by the manufacturer are appropriate. One other thing just to acknowledge and note that most of the spec sheets that we see really only identify particulate matter. In Virginia, we are not only concerned with the filterable particulate matter, but we're also looking at PM10 and PM2.5, which include condensables. So it's also imperative as an engineer to dig into the number and ask whether or not the PM emissions that they're supplying are giving you a full depiction of the emissions that you're looking at. So whether or not it includes condensables. So if it does not include the condensables, then we're going to AP42, and we're using an AP42 factor for condensables to add into the filter bowl that they provided. And we will also use AP42 for the SO2 emissions calculations. All right, next slide, please. So I'm going to skip a few steps. You know, we've run our UER calculations. We've determined what is going to trigger permit applicability and BACT applicability. We're going to then use our BACT analysis to apply our limitations or our control technologies and come up with our hourly emission limits for the facility. And we've set those hourly emission limits, the permits, and then you know, we'll move. I'm going to jump right into how we go about determining the total PTE for the source, or the annual emission limits. And you know, again, back in the good old days when we had facilities that were only putting in 2 or 3 engine generator sets or emission units, we could use a pound per hour limitation and an hourly limitation in the permit, which basically assumed that those units were going to be running at 100% capacity for the full time. And we would be comfortable in coming in below our NOx threshold that we're going to put on the source, or 100 tons per year that we're putting on the source. As the data center started to come along with more and more emission units, it was definitely becoming harder and harder for them to have any sort of operations which they could still stay below major source thresholds with. And we started to look into other alternatives for how to account for this. Now, given the circumstances that we've gone over in the last webinar and in some of this one, most of the data centers here are not operating at their maximum potential. They are typically only operating for the maintenance checks and the readiness testing, which is done at no or low loads. So data centers started to make the argument that, you know, we don't want to assume that we're running at 100% capacity when we're running at 0% or 10%. And as you can see from some of these examples on this slide, it's a big difference in the fuel consumption at no or low loads at those levels than versus at the maximum at the 100% load level. So that's what we started to use as an operational limitation, and also as something that we could use to determine a more accurate depiction of what their actual emissions are. So most of our data centers have moved over to fuel throughput for that. And again, for our emissions calculations, determining that emission factor, we're having to go back and look at each one of the load levels, taking what the facility is providing as a guaranteed emission limit or a guaranteed emissions number, and using the fuel consumption at that load to come up with an emission factor. All right, next slide, please. All right, so the next part of the process, we're going to assume that the facility is taking a limitation, and we'll just talk about NOx because that's usually the pollutant of concern, but they're taking a limitation to keep themselves out of non-attainment new source review or major source status. So What we need to then do is find an operational limitation that we can put on those units or on the facility that will help us guarantee that they stay below those emission limits. So in this case, we've identified the highest emission factor for this unit, which is 0.277. And we're basically back calculating from that 100 tons per year. So if your limit is 100 tons, 2.277 pounds per gallon, it gives us an operational limitation of 718,000 gallons of fuel. And that would be the federal enforceable limitation that we could put on the source to keep them out of major source thresholds. So that's easy, right? I said this was probably the hardest part of our process. But as you can imagine, this is for one engine, one emission factor. So as we are getting multiple engine manufacturers, sizes, performance packages, all going in at one source, developing that federally enforceable limitation can become murkier and becomes more and more difficult. And I'll also note here that we have 172 separate stationary sources, data centers, and we know that a lot are coming. It has not slowed down at all, and we get approached with why hasn't DEQ gone about a process to develop a general permit that could apply to all these data centers. And because of all these case by case situations and determinations on a unit by unit level, it really makes the development of a general permit that would really work very difficult. So that's one of the reasons why the general permit is just not an appropriate means to accomplish that. So we're still going through the minor new source review permit project program to do that. All right, next slide, please. So as we've started to use fuel and the facilities are bumping up against major source thresholds, we wanted to make sure that operational limitation that we were putting on those facilities was truly protective of that avoidance limit that the facilities were taking. So most of our facilities were using electronic control modules to monitor their fuel throughput. And when we started looking into the accuracies of those monitoring devices, we started to see that, they're not 100% accurate and that there is some fluctuation. And early on, when we started asking this question, it was very difficult to get manufacturers to guarantee their ECMs that they started using. So in some of our site evaluations and testing and research, we kind of determined that plus or minus 5% is what we would typically see for ECM accuracies for fuel throughputs. Well, when we started to apply that 5% to facilities, that was a huge amount of operations that they were losing out on. So facilities started to look into external fuel flow monitors with a higher accuracy to try to squeeze as much operation that they could out of those sites. We also started to see manufacturers coming around. They have a very large market here in Northern Virginia. So they started to do a little bit more research in it. And we're starting to see better and better guarantees of accuracies for those ECMs. So just keep your monitoring accuracies in mind as you are, developing these limitations, these operational limitations that you're putting into permits. All right, next slide, please. All right, because I have touched on the multiple units, multiple emission factors that we're seeing at facilities, and now we're starting to see more and more control technologies being installed at our data centers. We are the calculation for coming up with those operational limitations for fuel throughput becomes more and more difficult. Facilities really want to have the maximum flexibility possible to be able to operate any manner that they want, but still, be able to have a limitation that keeps them below major source thresholds or whatever annual emission limits that they're taking. So as of late, we've seen more creative methods of coming up with things like a fuel throughput equation, a formulaic equation that we will then build into the permit that kind of gives them flexibility to operate those units and still maintain an operational limitation on the facility. In this case, you'll see over here, mode A and mode B, we're taking into account SCR's controls in one of the modes and the uncontrolled part in another one of the modes. So by keeping the records and demonstrating compliance with this condition, then that's in effect meeting an operational limitation or fuel throughput that we're putting on the facility, the emissions units, to keep them at a major source thresholds. All right, next slide, please. All right, I'm not going to spend too much time on stack testing. I'll touch on this and dig into it a little bit more on the next webinar. But for our data centers, we typically require initial stack testing for NOx because that's our main pollutant of concern, the one bumping up against major source thresholds, and CO because that is an inversely proportional pollutant. So we are doing initial compliance for both of those. We are looking at a representative sample from each one of the makes and models out at the facility. And I will just say that we don't see many failing results from this, at least above and beyond what the manufacturer's recommending. Where we might see some failing results is if the units are not set up properly, if they have installed the wrong performance package on the unit, where they're going with a fuel efficient package instead of a NOx efficient package. Those are, some of the things that we will see that for reasons why they're not meeting their emission limits in the permit. So concurrent with the CO and the NOx, we'll do visible emissions evaluations to demonstrate compliance with our opacity limitations that we put in the permit. Our opacity limitation for emergency generators in Northern Virginia is very low. It's 5%. So really seeing any visible emissions coming out of the stack would indicate to us that the unit's not set up properly. There might be a problem or an issue. So really those tests are verifying that the unit is set up appropriately. All right, and another reason why we're using representative samples is because, well, with the concentration of engines at our data centers, having them test all of the units, we have 7,000, we had them test 7,000 units, 3 1-hour tests. It's kind of working against what our goal of reducing emissions is. So we are satisfied with a representative sample and the data that it's providing us to give us reasonable assumptions that the units are being set up appropriately and meeting the emission limits in the permit. Next slide, please. All right, so when, I can still remember back to the days when we didn't know what a data center was. It was just a building with some emergency generators, and it was just engine gensets, right? And it wasn't really until 2007, 2008 that we started to see the term data center pop up. And it took a little bit of time for us to then realize that this train was not slowing down, that we were going to get more and more of them. So we started to take a look at the way that we were permitting facilities with engines, and knew that data centers with the amount of emission units being put in there wasn't the same as what we thought of in the past, where it was a hospital or an office building with some backup power generation on site. This was just something, way different, and this just wasn't going to be a passing fad for us. So we started to really dig in and say, okay, what could we do to, help curtail some of the impacts from these facilities? So, as most of Northern Virginia is non-attainment for ozone and located in an ozone transport region, we started to look, at this aspect first. What operations could we curtail at a data center was when ozone formation was at its worst. We're constantly told that on code red or code orange days that we should, try to not mow our lawns or not, fill our cars with fuel in the area to try to do our best to minimize those impacts on those code days. So what could we try to influence a data center to do to take some of the same precautions? Now, we really don't have, and data centers don't have any control as to when they're going to get true emergency situations. But the one thing that they do have control over is when they do their scheduled maintenance checks and readiness testing. So we started to limit those operations during peak ozone formation times. Now that wasn't always a popular decision, especially with some of the localities that have, sound restrictions. They're trying to keep operation from happening at night. So that has been, something that facilities have struggled with to try to work around. But it has, seen its benefits and uses here in Northern. So, also continuing along with this theme, okay, what other things are optional or within the control of the facility or DEQ? And one of these was our initial compliance testing that, our initial compliance testing that we were putting in the permit was asking the facility to run for 3 hours a day, which is not something that we necessarily wanted. So we started to provide for allowances for stack testing to be pushed outside of the ozone season. So within 90 days of the end of the ozone season, we'll then require the stack testing for these units. So it's trying to do our best to be as proactive and as protective of ozone formation, during those peak ozone formation times. So facilities started to push back, especially on the activities that they had for commissioning. They wanted to get their projects done. They have outside vendors installing the units and running through those commissioning activities. So, they had arguments about safety was their number one concern. And then, costs of bringing on these outside outfits out, outside of the normal workday. So we started to look at that and see what we could do to alleviate that. And so we do provide for some allowances for the, we call it integration operational period, but the shakedown of the units, as long as we're having good ozone quality days. So we have built in some allowances for those activities during, the ozone season, but as long as they can demonstrate and they have the data to back up that it's on a code green day, that they can go ahead and perform those activities. And then, lastly, one of the things that as we got more and more of these emission units at a facility is that We used to have monthly rolling totals, and for our data centers, with the amount of emissions units that they have there, they could operate 2 or 3 days for an emergency event and then be exceeding their annual emission limit. So one thing that we started to look at was 365 rolling day totals, so that they're able to identify exceedances, potential exceedances, much quicker than waiting for a full month to pass. So those are some additional things that we have looked at and incorporated into our permits for data centers. All right, next slide, please. Okay, so wrapping up, finally, right? One thing that we have started to see as they are starting to pack more and more engines into these single stationary source sites and live underneath those 100 ton per year limits that they have to avoid major source thresholds or non-attainment new source review, we've started to see them add on SCR control technology. Other reasons why facilities are adding on more controls is to become a non-emergency unit for Virginia's definition, and still remain a emergency unit under the NSPS Quad I, which would require Tier 4 finals. So what we would typically see are Tier 2s with add-on control technology. So basically Tier 4 equivalent engines. So as you can see, this is just an example of one company that has been with us, and probably the most common company that we see for data centers in our region. But they had 2,600 units permitted, and only 592 of those had SCRs, DOCs or DPFs. And then now the applications that we see pending, the numbers skewed in the other direction, where we're seeing only 105 uncontrolled units and almost 500 with controls. Other trends that we're seeing, the 1750s were the size of the unit, 1,750 kilowatts, or the size of the engines that we would typically see at the beginning, or 2250s. Now we're starting to see the 3 megawatt units we've been seeing the 3 megawatt units, but we're starting to see more of the 4 megawatt units. So they're getting bigger and bigger. And that's why, Stan's mention of the BACT of 6 grams per brake horsepower hour, it's worked. It's been so cool. It's really driven the industry. There is a manufacturer out there with a performance package that is made specifically to meet Northern Virginia's BACT requirement, or Virginia's BACT requirement. So for me, that is very cool and a big success for us that we are able to influence and impact the facilities and the industry. We're starting to see more requests for renewable diesel fuels to be allowable fuels in their permits. So the biggest one that we see is hydrotreated vegetable oil. And as those become more and more available, to the facilities, we'll see more and more requests to have that done. Because of the energy, whether it be production restraints or transmission restraints, we're seeing more facilities look to prime power generation on their site to be able to make and use their own power. So we're seeing requests for, when we have permitted data center with combustion turbine engines, natural gas fired, to be able to power the facilities. And then, and just to touch on the renewable diesel fuels, the diesel is the bread and butter of the industry. We have not seen many natural gas fired engines, mainly from what we hear, due to the interruptible nature of natural gas, and the cost and expense of getting a pipeline to the facility, or just storage not being a prevalent thing for natural gas right now. We have permitted one That was about 3 years ago, and I don't think we've seen a shovel in the ground for that natural gas fired facility yet. So just wanted to give you a heads up what we're starting to see in our neck of the woods as to changes for the facilities. Next slide, please. And that will do it for me. So I appreciate your time and your patience with me, and I'll pass it over to Sana.
Thank you, Justin. And as you can see, as Justin so eloquently explained, it's a very complicated process, data centers and air quality, and why Virginia is the expert on this. And our friends in Virginia have spent a lot of hours with us for us to be able to do this in Maryland. So what I'm going to present for you guys today, my name is Sana Therasak. I'm the manager of the Air Quality Permits Program, is our Air Quality Permit to Construct case study. So there's a data center campus that we just recently permitted in Frederick County. This is our first very large data center. What I was going to do is walk through the case study of what we needed to do and what's very specific or unique to Maryland, and how we issued this permit for this facility just recently in January. Next slide, please. Okay, so to give you a little bit of background, on July 1st, 2024, we received an air quality permit to construct application for a proposed data center facility, including installation of 168 emergency generators, each rated at 3,000 kilowatts and each equipped with a selective catalytic reduction emissions control system. And then an additional 4 generators that do not have separate control devices that are rated at 1,000 kilowatts. What's really important about this July 1st date that's significant is that that was the effective date of the critical infrastructure law that was passed to allow data centers to submit an application to the Department of the Environment without having to go through the Public Service Commission as an electric generating facility. And so that law was passed and defined data centers as critical infrastructure, as it is important throughout the country to have data centers up and operating. And so on July 1st, as soon as the effective date of that law went through, that application was in our building. There are 4 total buildings in this project. There's 42 of the larger generators per building, and then 1,000 kilowatt emergency generator in each of the buildings. And so, like I said, the permit was received on July 1st, and the permit was just issued in January of this year. Construction is occurring now through 2029. Next slide. So what's unique to Maryland, I think, is Virginia stated they don't have a public review process for their minor NSR program. We have a public review process for certain minor sources. Our law states that emergency generators or any facility that's subject to federal new source performance standards under the Code of Federal Regulations 40 CFR Part 60, they have to, at a minimum, provide an electronic notice if any of the facilities are subject to a federal NSPS, and an additional requirement, there's even a more elaborate public review process. But for just NSPS sources like emergency generators, they are required by Maryland law to, at a minimum, provide an electronic notice of the permit application and allow the public to comment on the permit application for any air pollution sources subject to NSPS. So we do a web notice and we put it online, and anyone can comment on the application, but the process moves forward. For data centers in particular, that was different. We decided that we needed to have more public engagement, as this is a pretty controversial, or at least a high public interest topic. So we also added a meeting to receive comments on the draft permit. So first we receive comment on the application, and then when the draft permit, if the application is determined to be approved, then we would recommend that we issue the draft permit and it's open to public comment. So we allowed the public more access and opportunities to participate for data centers. Next slide. Next slide, please. Thanks. So Maryland application requirements. Oh, no, sorry, the other slide. Back up one more. Maryland application requirements. So this is extremely unique to the state of Maryland. Maryland law, when we talk about public participation for minor NSR, one of the and this is similar to Virginia that Stan mentioned, that one of the application requirements is they absolutely have to provide evidence of zoning approval. So with that application, what we require is, evidence of zoning approval in the form of a letter from the local zoning authority stating that proposed project is an allowed use. Like you can't say we've been existing and we're allowed. It has to be that proposed project in the letter. And most of the people most of the local zoning authorities in the state of Maryland are familiar with our requirement and are able to provide that letter to us that the applicant puts in their application. One of the other application requirements is an environmental justice EJ score. This was new in 2022 that any applicant subject to public review must provide a report so that they are aware and the public is aware of what the EJ score is using the Maryland EJ scoring tool on our website. And then the third and final requirement is unique to data centers. The data center critical infrastructure law required that not only they meet air quality requirements, but that they also have to meet local noise ordinances or noise requirements. We are not the delegated authority for noise, and local jurisdictions enforce the noise regulations. However, we require evidence in the application that they comply with the local noise requirements or they're working with the county or the local authority on obtaining approval. For this particular case study or for this particular application, there was a report that showed that their initial noise study was approved by the county. Frederick County is the noise authority here. And then with each successive building that they build, they have to amend that and get approval from there. Next slide. Okay, so Maryland ozone non-attainment areas. So I made this big red triangle so you could see that all of central Maryland is what was originally determined to be a severe non-attainment area. So our major source thresholds for ozone for the precursors, NOx and VOC, are 25 tons per year each. That's very low. But as you can see in central Maryland, inside that red triangle, it's a very desirable location. So we still get a lot of people coming here to want to build air pollution sources in Maryland, but we are a very restrictive area of 25 tons for NOx and for VOC. And even though air quality has improved over the last 30 years, we still maintain that major source threshold, even though we are currently, I believe, classified as moderate. And then I think one of the counties might be classified as attainment in the near future in that triangle, but we will never backslide. So we will always be 25 tons in those areas. And then because the counties on the western part of Maryland on the eastern shore or in the ozone transport region, like Virginia, we still have a lower threshold, which is major source threshold for NOx is 100 tons per year and VOC is 50 tons per year. Next slide. So applicable air quality requirements. So in addition to, we have one state-only requirement that regulates capacity from engines. The emergency generators at a minimum must meet the federal NSPS engine requirements. We don't have anything else specific to that other than we reference the federal requirement as our applicable requirements for emergency generator engines. Each engine must be certified to meet the emergency emission standards and has to be constructed, operated, and maintained according to manufacturer specifications. And they can only be operated for testing, maintenance, and emergency purposes, and they can only use ultra-low sulfur diesel fuel. Our requirements are not as stringent. They are allowed the 50 hours of non-emergency operation, but not for peak shaving or demand. I think there's like a section in the rule that still allows that. But they are allowed up to 50 hours of non-emergency for things that we do not classify as an emergency. But it's still pretty restrictive. And as you can see with the data centers, they're so restricted to meet the 25 tons that they're not even going to be allowed the 50 hours per engine. Next slide. Okay, so the overarching limit at the facility, because it's located in Frederick County, which was inside that red triangle that I had on that map, is 25 tons of NOx per rolling 12-month period. That is the overarching premises-wide limit. They cannot exceed that. But complying with that limit, because it's so low, reduces the potential emissions of all of the other regulated pollutants to less than major source levels. So we don't really have to worry too much about the other pollutants because of this limit that they have to comply with. NOx limits their operations. Next slide. Operational limits. So I talked about the overarching premises-wide limit. That is the limit. They have to be under 25 tons of NOx. How they do that, we do provide a little bit of flexibility. We have both operating hour limits and diesel fuel limits. Justin really went through great detail on how that those fuel usage limits are determined. We are, like I said, we allow it to be a little bit more flexible because as long as they can demonstrate they're under 25 tons, they could go over these numbers. But these numbers are really more of a guideline that if you're approaching these numbers, you need to start taking a look at whether you're going to be hitting that 25-ton major source threshold for NOx. But let's talk a little bit about the operating limits. So these operating limits, if you can see each engine, they have proposed that they're only going to do readiness testing for 3 hours, etc. So I think this adds up to like 10 hours a year per engine. So even though you're allowed 100 hours for testing and maintenance, they are proposing that these engines in particular will only have to operate 10 hours a year for testing and maintenance. And then Maryland required them to incorporate, at least at a minimum, the emergent, what they believe would be like a normal emergency operation, like how many power outages or averages for the year. So that's kind of that additional hours, and also includes performance testing, readiness testing, or additional, if we wanted them to do stack testing, that's kind of in that limit. And again, it's not a hard limit if they're still under 25 tons, but that's more of a guideline per generator. But because 10 hours per generator is exceptionally low as far as the proposed testing and maintenance schedule, and the NSPS requires them to operate and maintain their engines in accordance with manufacturer specifications, we did require the manufacturer to confirm that their proposed testing and maintenance schedule still met manufacturer guidelines. And then for the diesel fuel limit, these numbers look unusual because they actually asked for 275,000 gallons and 90,000 gallons. But as Justin mentioned, fuel meters are not particularly accurate. We took 5% off of these numbers, and I know that makes the gallons much lower. The applicant had a lot of concern until they recognized that it's really only if their rolling 12-month is, is approaching 25 tons. So they can go over those numbers. They just have to demonstrate to us, and they're going to be submitting, keeping a lot of records and submitting reports to that effect. Next slide. So control device requirement. So in Virginia, because they have a 100-ton major source threshold, a lot of those engines did not need controls. They absolutely need controls here. So the 168 engines are going to each be equipped with selective catalytic reduction SCR control systems to reduce NOx emissions. They have to continuously monitor all of the performance indicators that are recommended by the manufacturer: differential pressure, catalyst bed temperature, urea dosing rate, and NOx concentrations before and after the catalyst. One of the other things that Virginia did point out to us was very interesting that we talked about is that because the SCRs rely on the diesel exhaust fluid that's injected, which contains urea, or to control the emissions of NOx, that concentration or effectiveness. Yeah, I see that. Thanks, Jesse. I'll talk really fast. That concentration or effectiveness will need to either be measured monthly, which is something that that the company may do, or it will be replaced every 12 months because there is a shelf life on that. And we want to make sure that when they do need to use it, that it's actually active. Next slide. I'm going to talk really, really fast. Okay, testing requirements. So I know a lot of people want to talk about this a little bit more. We talked to Virginia and about what they were doing, and they have 20%. We picked the 14 because there's 42 in each building, so that's 1/3. In our permit, we are requiring them to test the first 14 generators, and they're going to have to, demonstrate, or they're going to have to provide us with the kilowatt output, corresponding generator load, fuel consumption, NOx concentrations, etc. The SCR catalyst bed exhaust temperature, all of that information, and that's something that we're going to take back and look at. One of the things they applied for is they have 2 different models that they are not sure they're going to be installing. So they're not sure which ones or how many of each, and they might have a mix of both. So when we developed their limits, they based it on the worst case fuel or pound per gallon of fuel for each of the models to develop the absolute worst case in case both engines are there. So we do want to have them at least test their first 14, and then we may be reevaluating that to something where it's representative. It really just depends on how they build this first building out. to determine whether additional or subsequent stack testing in that building or other building will be required. Next slide. So record keeping. So this is kind of the most extensive part. They have to keep records of all fuel usage, sulfur content, operating hours, all of the operating parameters that we require for the control devices, and when the urea is replaced or when they measure it. All records of manufacturer vendor literature, maintenance performed, EPA certificates of conformity, and the stack emissions tests, and the records of premises-wide emissions of NOx. It's actually, we're keeping it all, having them keep records of all pollutants, but it's really the NOx that we want to be watching so that every rolling 12 months, they, and you can go ahead and go to the next slide, Jesse, thanks. Basically, we're going to have them doing reporting to us semi-annually, that information. And also if, you know, a rolling 12-month period is over the 25 tons, they have to report that within 15 days. So that we can go back and check, or any of the occurrences, whether the emissions, the fuel consumption, or the operating hours are greater than the limit specified in the permit. And then they also have to submit annual emission certification reports. And then next slide, hopefully this is the last one, I think it is. So we get 2 bites at the apple. We have an air quality state permit to operate. So even though they're going to be a minor source in Maryland, or a synthetic minor source, I should say, because they're going to try and operate under this overarching premises-wide limit, they also have to obtain a 5-year renewable state permit to operate from us. So the initial permit allows a temporary operating permit for 180 days. And so basically they're going to have to demonstrate compliance. And then in that 5-year renewable, you know, we'll be able to add some additional conditions and get another, you know, take on it once we get some of the information from the facility itself. And so that was a really quick overview. I think that might have been my last slide. So
Now just jump in
hopefully-
there, Sana. Hey, this is
Yeah,
this is Stan from Virginia. I was just going to jump in there and say that is one difference from Virginia, is that when you get air minor new source review permit, unless you're Title V and you have to come back and get a Title V operating permit, which is usually not the case, then that one permit you get for Virginia is all.
right.
It's
So
both.
we have we have a state only operating permit, and we are requiring them. All of our synthetic minor sources are required to have that 5-year renewable permit. So we do get to reevaluate that every 5 years, what's going on. And since this is going to be built over time, you know, that's where, you know, we have a little bit more time to kind of look at the data over the next, you know, 5 years, and maybe even add more requirements in the operating permit as needed. I do see a question in the chat. I'm just going to go ahead and address this. I know we don't have a lot of
Yeah.
time,
Yeah,
but yeah,
just-
okay, yeah. Sorry, go ahead, Mark.
no, go. I was going to ask you to just start answering the questions.
Sure. Yeah. So has there been any pushback on aggregating projects? Yes. I mean, and no for us from Maryland. We've had a lot of proposed applications come in or proposals. They want to, you know, buy this gigantic site and parse it out in a way that they think is not aggregating or aggregating. And whenever we give them our answer, because 25 tons is so restrictive, that we usually don't see them again. But I'm sure Justin can dive in a little bit on their end.
Yeah, I mean, for us, it's a little bit different. We have not received much pushback, and that's mainly the way our BACT is set up, in that facilities will have to meet the NOx BACT of 6 grams per brake horsepower. So they're meeting that in their past, you know, permits and applications already. So when we get to triggering other pollutants for BACT analysis, like Stan mentioned, it usually what we have seen historically is that things become cost prohibitive to put on additional controls, so that the proper operation and maintenance then becomes the BACT requirement for the facility. So there's really not any additional controls that the facility is having to go back and put on.
Sorry, Sana and Justin, I had an issue with my mouse and I had to restart Teams and everything. But thank you for taking care of that first question. The other question, let's see. When you require testing, at what load do you require the test?
Yep. So for Virginia, because NOx is our pollutant of concern, we're typically requiring the testing at 90% of load or greater, because that's our worst case load banner scenario. There may be other reasons if facilities taking a limitation because they have SCR control for their uncontrolled numbers to be lower, then we might have them test at those lower loads as well to demonstrate compliance with those uncontrolled emission limits. But predominantly, we're requiring the testing at 90% a load or greater.
Yeah, and that is the same in Maryland as well. We are requiring the testing at 90% of the load. And one of the questions we got from the applicant is that they're not really going to have the load yet because the buildings are still being built, and some of them, we're requiring it with 180 days. They can bring in a load bank as needed to require the test, or they can ask for an extension. Again, we haven't gotten there yet, but they can also ask to test it at a lower load. But we are requiring in our permit 90%.
And related to that, how often do you require a stack test? Is it every 5 years?
So Virginia, we only require initial stack testing to begin with. We do have the ability, if compliance is out there and they determine maintenance isn't being done properly, or any sort of concern that emission limits aren't being met, we have the ability to require stack testing at that time. However, our permits typically only require stack testing for initial performance testing.
Okay. And what is your response to facilities when they say they don't want to turn on emergency generators just to test?
I mean, our response is that it is a typical requirement of data centers and of engines. So it's something that we do require, and we'll look at things on a case-by-case basis to determine what is an appropriate amount of stack testing, or if stack testing isn't appropriate. But we do have that regulatory authority to require stack testing and demonstrate compliance with the emission limits that we're putting in the permit.
Right. And just to chime in from Maryland, if they don't test their engines periodically, or even, if they're not conducted, they have to operate and maintain them in accordance with the manufacturer specifications. But they also want to be able to use them in the event of an emergency that's outside of their control. We'd like to make sure that those emergency engines are capable of achieving what they're achieving. When you're mass producing all of these engines, if you don't ever run them or test them as often as you need to, they may not run when you need them to actually run in the event of emergency.
And then I have a question that a lot of people seem interested in. Has Virginia received any pushback from EPA on the formulaic approach for limiting fuel usage? We tried using this approach to develop an equivalent fuel usage limit in the past, and EPA Region 5 pushed back and said the limit was not practically enforceable.
Yeah, as of right now, we have not received any sort of pushback or comments concerning that value or that approach.
Okay.
Yeah, we have not either. Our permit does not require EPA approval. It's a synthetic minor permit, but we did have a lot of discussions with EPA on this topic. Because of the extensive amount of record keeping and reporting they have to do, we feel that we'll be able to see it, if there's an issue with just having the fuel usage. In Maryland, they're not hard limits. They are more like guidelines, but they're going to be reporting and keeping those records every rolling 12 months. And so they will know when they're approaching those numbers that they need to be demonstrating that they're still under 25 tons.
Got it. Does Virginia have data on actual emergency operation of the data centers? And if so, what have you seen?
I mean, we do. That's one of the required records that facilities are allowed or required to keep. They're required to keep the amount of operations that they do and the reasons for those operations. But our experience has been that they typically do not run for emergency reasons, mainly because of our grid reliability and our strict definition over what can operate for emergency purposes. So it's really only for sudden and unforeseen losses in grid power. So that's really the only reason they can operate for emergency. And like I said, we have had very few events historically that require emergency operation.
And Justin, I'll just chime in there. That was one of the issues that Tamara mentioned on the last session, the legislature report, the JLARC that was done here in Virginia. And I think that was something they looked at and confirmed that there was just very, very little operation during real emergencies, particularly in the Northern Virginia area. They just don't lose power that often. That's one of the reasons the data centers go there.
Yeah, and then from Maryland perspective, we actually require them to account for some amount of normal emergency operation. So this particular applicant had to go back and look at average power outages and times in the area where they're locating, just to kind of get an idea of when they might possibly operate for normal emergencies, not like in a catastrophic hurricane or something like that, where power might be out for multiple hours or days. And it turned out to be something like 5 hours or a few. I mean, it was like there was hardly anything, as far as like, so our grid is fairly stable. And then also in the event of a catastrophic emergency where these actually have to run for emergency power, there are a lot of other issues or concerns with not having data available during these emergency things where it's a hurricane or a tornado or something where there's excess power outage. You probably want to have access to all of your data services as well during that time. So there is a little bit of a trade-off to having those generators operating when there's for longer periods of time, but we just haven't seen it yet.
Okay. Do you all mind, we are at time. Do you all mind staying on for just a few more minutes to get through a couple more questions, or should we just go ahead and end and maybe try to follow up with some people afterwards?
I'm perfectly happy to stay on since I ate up most of the time.
Okay.
I could stay on for a little bit longer. I do have another meeting, but I told them.
Okay. Yeah, there's just really a couple more. So I appreciate that. And I understand, yeah, some attendees are having to jump off, but at least for those who are still on. So I'm not sure if this is something that you can show right now, but it's an interesting question. Are you able to provide sample emission factor calculations when operating at 75% load? Having a visual would help.
I don't think we had that in our presentation, but it is something that is built into our permit engineering analysis of us walking through each one of those different load bands and running those calculations. So we do have available, by request. I'd be happy to provide some examples.
And then for sites with a lot of engines, do you typically require initial performance testing for all engines or just a select sample?
I mean, again, we really hang our head on that 20% factor. We do take in certain conditions into account and treat it on a case-by-case basis, but usually our starting number is 20%, and different circumstances are going to push us in different directions as whether or not we're requiring more or less. But yeah, 20% is typically what we've been requiring for data centers.
Okay. Let's see. Trying to figure out how to prioritize here. Okay. For the Maryland data center permitting example with around 10 total operating hour limits per engine per year, how is performance testing accomplished within the low operating hour limits?
Yeah, that is a very good question. That is something we asked them for, which is why there's an additional 2 hours, which would be part of the load testing. They would make sure to conform to meeting load testing requirements and their stack test at the same time, with the additional 2 hours, so they could have the 3 1-hour tests. And because of the redundancy, and I think Tamara talked about this a little bit more about the redundancy of the engines, if for some reason that engine was not able to test, and they had to wait to be able to operate, at their other 10-hour limit, period, they have other engines as backups, so it's okay if they're kind of hedging their bets that these tests are going to be compliant and it's going to show. And there's not like a specific hourly limit that we're holding them to, but we just want to get the NOx emissions generally from these types of engines so that we can ensure that they're less than 25 tons of NOx. So, so we did make sure that they had the additional, my slide actually shows there's an additional 2 hours and then an hour for load testing, and that would be the 3 hours that they need for the performance test, and just hope it's compliant.
Thank you. Let's see. Okay, this is kind of a long one. As Virginia or Maryland heard from permittees, the issue that urea injection may not always operate during T&M operation due to the short runtime or low temperature on the catalyst control device. This came up during inspection questioning about why a control device was not in operation during running.
So for us, for SCRs, because all of ours are going to require an SCR control device, we actually calculate our emissions and our limits based on the SCR not operating all the time. And it's really not going to operate all the time until the catalyst reaches a certain temperature to minimize, and I think I meant to mention this, but I was kind of going fast, but to minimize any ammonia slip issues, but also to ensure that the SCR is like able to control at the level that it's supposed to, it has to reach a certain temperature. So we have tried to calculate exactly, at what loads and what run times would be uncontrolled, and that's part of our calculation as well in the limits that we have in our permit. So we are accounting for that. It's unlikely that the SCR is even going to be running during some of the minor testing and maintenance of the engine itself, but during the load testing, it absolutely will be running.
All right. Well, I think there's a couple other questions, but we are a bit over time now, so I think we can go ahead and wrap it up. Sana and Justin and Stan, thank you so much for your time today, and thank you everybody for your engagement. As this slide says, the recording and slides will be made available to all of you who registered. I will send those out following the webinar. And if you need a certificate of attendance, please email me. If you need a certificate of attendance for multiple people on your staff, I would appreciate if you could send me a list of names and emails as opposed to individual people reaching out to me. If possible, it'll make it a little easier. I think that is everything, and hopefully we will see some of you at our next couple of sessions that we have planned on April 3rd and April 17th. And so, I hope everybody has a great rest of their week, and we'll see some of you in a couple of weeks.
Great, thank you.
Thank you.
Thanks.